awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. So let's continue chapter 1 with another subtopic, which is 1.4 charge in a uniform electric field. Okay, so today we are going to discuss 4 examples in this subtopic to enhance your understanding. So let's get started. Okay, before we discuss the examples, let's recall about 4 cases of charge in a uniform electric field. Okay, so as you know, okay, when we have a 2 plate, which is positive and negative plate here, okay, so the electric field between the plate is an uniform electric field. While when we have the isolated charge, for example, positive charge here, so this electric field around the charge is ununiform electric field. So now for subtopic 1.4, we are going to discuss about the charge in uniform electric field. Okay, so now look at the first case. We have a particle with positive charge Q and it's stationary. Okay, why it's stationary? Okay, for example, we have a plate here and this view is a side view. Okay, the side view, and we consider the wake. Alright, so since this is a positive charge, therefore the electrostatic force on the charge on this particle would be upward direction. Okay, so in this direction, because positive charge will be attracted to the negative plate. Okay, and we have a wake, the wake of the particle. Alright, so the direction of the wake is downward. Okay, so when we write the total Fy is equal to Ma, so since the charge is stationary and the position is between the electric field, so we can write Fe, the electrostatic force minus the wake, and it's equal to 0. Okay, therefore we will get Fe is equal to W, where Fe is equal to Qe and W is equal to mg. Okay, and look at case 2. Okay, so for the case 2, we have a positive charge and it's moved at constant speed. So this also side view. So from the side view, you can see that when the positive charge enters the electric field between the plates, the electrostatic force should be upward because this is positive charge. Alright, and the wake is downward and we have the acceleration in this direction, which is equal to 0 since V is equal to constant. So remember, for constant speed, acceleration is equal to 0. Therefore, we also can write Fe, okay, Fe is minus mg, Fe minus mg is equal to Ma, and this equal to 0, therefore Qe is equal to mg. Okay, and look at case 3. This case, we can look at this plate in 2 types of view. Okay, the first we can see from the side view or from the top view. Okay, so let's say this is from the top view. Okay, if this case is from the top view, so the direction of the wake is actually not downward, but the direction of the wake is into the page. Okay, so when the electron, here we have electron, so when the electron enters the electric field, so this is negative. Okay, so there is the electrostatic force upward. Because the upward plate is the positive plate, therefore, the direction of the electrostatic force is upward. Okay, ada yang tanya, Madam, kenapa W dia tidak ke bawah? Okay, dalam you punya lecture note, contohnya, kenapa tak ada W? Kenapa kita ignore W? And kenapa case 1 and case 2 ada W? Okay, in case 3, this is from the top view. Okay, bila kita tengok daripada atas, Maknanya kat mana kita punya direction of W. Okay, the direction of W should be into the page. Into the page. Okay, awak kena bayangkan awak tengok daripada atas. Therefore, the electron is moving to the, kalau awak tengok daripada atas, awak tengok daripada kiri kan. So, the direction of the electron will move towards to the left direction. Okay, so dia punya W is into the page, the direction of W. So now look at to the motion of the electron. Okay, when the electron enters the electric field, you can see here, okay, we have the value of Ux equal to U. The electron enters the field at horizontal direction, projected horizontally. Remember, in chapter 2, in semester 1, you have learned about projectile motion, right? So we have an object that projected horizontally. So this electron is projected horizontally. Since the electron is projected horizontally, therefore the value of the horizontal velocity Ux is equal to U. Okay, jadi kalau dalam soalan nilai yang diberi pada awal tu, nilai velocity U tu adalah Ux, because the electron is projected horizontally, and Uy automatically it's equal to 0. Okay, so now the electron enters the field, start from here, okay, and the electron leave the field, okay, at this point, and the horizontal displacement traveled by the electron is equal to Sx. Okay, so that one is the horizontal displacement, Sx. So when the question gives you the length of the plate, so it's actually the value of Sx. Okay, and you get here, okay, why the motion of the electron is moving in upward direction. Okay, so remember, since this is electron, it will move upward because there is the electrostatic force upward. Okay, electron will be attracted to the positive plate. Okay, so sebab tu dia bergerak ke atas, dia akan deflect ke atas. And when it enters the field at this position, okay, let's say saya letak starting point is A and this is B. Okay, so when the electron leave the field at point B, there is a final velocity V. Okay, so we need to calculate V, but you need to calculate first what is Vx. Okay, and remember the value of Vx is equal to Ux. Okay, and how to calculate Vy? So remember, we have equation Vy is equal to Uy plus At. Sorry. Okay, since the direction of the electron is moving upward, therefore the sign of the acceleration should be positive. Alright, since Uy is equal to 0, then Vy is equal to At. Okay, and when you calculate A, okay, so the equation of A, remember, okay, macam mana kita dapat A ni tadi? Okay, so kita tahu kan? So total Fy, okay, saya tulis kat sini, total Fy is equal to Ma, and look at on the electron, we just have the electrostatic force. So now we substitute here, Fe is equal to Ma and QE is equal to Ma. Therefore, A is equal to, ini saya boleh letak Q ataupun you nak letak E. Kat sini letak E kan, boleh tukar jadi Q. Okay, kalau you nak letak Q, because it's electron charge, so you letak Q lah. Okay, therefore, A is equal to QE over M, where M is the mass of the electron, Q is the charge of the electron. Okay, so now when A is equal to QE over M, so when we substitute in this equation Vy, tadi kita dah dapat Vy is equal to At, therefore Vy is equal to A tadi berapa? QE over M and times T. So E here is Q lah. Awak nak guna E boleh, nak guna Q. Okay, it depends. Okay, and in order to calculate the final velocity at point B here, okay, you can see we have equation of the resultant velocity, okay, equal to, okay, square root Vx squared plus Vy squared. And you can also calculate the direction, okay, the angle, okay, where theta is equal to inverse tangent Vy over Vx. Okay, so kita boleh carilah berapa angle dekat sini masa elektron tu keluar daripada electric field. Boleh? Okay, good. Okay, tadi kita dah cerita pasal horizontal displacement, where the horizontal displacement travel by the electron Sx equal to uxt. So letak dekat sini uxt. Okay, so how about the vertical displacement? Okay, so since the electron is traveling from point A to point B, therefore we can calculate what is the vertical displacement that travel by the electron. So it's equal to, kita ukurlah yang ini. So it's equal to Sy. Okay, so remember the equation of Sy. Asalnya equation Sy apa dia? Mana saya nak tulis ni? Saya tulis bawah sekali. Okay, so Sy is equal to Uy plus half AT squared. Since Uy is equal to 0, therefore Sy is equal to half AT squared. And you can substitute, okay, the equation of A tadi, which is A is equal to QE over M. Okay. Okay, nanti kita tengok soalan, baru you akan nampak. Alright, good. Okay, let's move to the next slide. So now look at to the diagram on your left side. So we have positive and negative plate, and you can see here this positive charge will be attracted to the negative plate and it will move upward. Alright, so the direction of Fe, awak boleh nampak sini, is labeled upward. Okay, and therefore, okay, total Fy is equal to Ma, and this is from the top view. Okay, kalau you tengok daripada atas, and then the direction of the weight should be into the page. So if you look at from the top view, so total Fy is equal to Ma, and it's equal to Fe equal to Ma, and it's equal to QE equal to Ma. Therefore, A is equal to QE over M. And if the charge start from rest, therefore U is equal to 0. And when there is a change of the kinetic energy, when the charge arrives at this point, there is the final velocity of the charge. Therefore, the charge is gained in kinetic energy. We can calculate the change of the kinetic energy, K final minus K initial, okay, where it's equal to, okay, half mv squared minus half mu squared, and this is equal to 0. Okay, for this case, we also can calculate what is the potential difference, where potential difference equal to delta V, okay, equal to W over Q naught. And then you can relate that W is the work done when we have the change in the kinetic energy. W also equal to delta K. Alright, and W also equal to Fd, where F is the electrostatic force and D is the distance traveled by the electron. Okay, so when we substitute these two equations of W in this equation of delta V, we're gonna have two types of equations for potential difference, where potential difference delta V can be equal to delta K over Q naught, and also delta V is equal to Fd over Q naught. Dekat mana kita nak apply equation ni, you kena buat soalan baru you tahu. Okay, and if you look at to your right side, okay, we have another two diagrams here, which is figure 1 and figure 2. Okay, this is also the condition where the charge is moving parallel to the field. Okay, now look at here, we have a positive charge and it will be attracted to the negative plate and it will move to the right. And for this motion, we can write total Fx is equal to Ma, and F kita adalah electrostatic force, and QE equal to Ma, and A is equal to QE over M. Okay, boleh? Okay, so same goes to this one. we're gonna have A is equal to QE over M. Okay, so before we proceed to the examples, so I want to highlight here how if we look at this plate from the side view. Okay, kalau you tengok daripada side view, you need to consider the weight, right? Awak tengok daripada tepi kan? So, FE is upward, so there is the weight downward. Okay, therefore, we can write the total Fy. Okay, yang merah ni tadi adalah top view. So, kalau top view, the direction of the wake is into the page. If the side view, the direction of the wake is downward. Okay, so mungkin ada antara kamu yang tanya kenapa ada buku ni tak ada wake. Okay, sebenarnya dia ada, tapi dia adalah pandangan daripada atas. Okay, so now it's equal to MA. Okay, so from here we have FE and wake is downward equal to MG and equal to MA. Therefore, you're gonna have your acceleration is equal to QE, since FE equal to QE minus mg over the mass of the proton. Okay, sebab ini positive charge, so proton. So kita ada, nampak you ada dua equation A dekat sini. Okay, so the blue one is from the side view and the red one is from the top view. Okay, same goes to this one. Okay, let's say this is a top view. Okay, you can imagine the direction of the wake should be into the page. Kalau kita tengok ini daripada pandangan tepi, okay, so the direction of the wake should be downward lah, W. Okay, and now we consider the direction of the motion is in X direction. Sebab itu dekat sini saya tulis total Fx equal to MA. Okay, therefore, so the only force that we have in X component adalah Fe. Therefore, Fe is equal to MA. So, A is equal to QE over M. So, let's move to the examples. Okay, example 1, we have two parallel plates are separated 5.0 millimeter apart and the electric field strength is given between the plates is given 1.0 times 10 power of 4 Newton per coulomb. Okay, so a small charge of positive 4.0 nanocoulomb is moved from one conducting plate to another. Okay, so calculate the work done on the charge and calculate the potential difference between the plates. Okay, so here I have the plates and the direction of the electric field must be from positive to negative plate. Okay, in this direction. Alright, so given that the question gives you that the plate is separated by 5 millimeter apart, means that the value of D is equal to 5 millimeter. Okay, and given that the electric field strength is equal to 1.0 exponent 4 Newton per coulomb. Okay, and we have a small charge which is positive, so means that this charge is from here. Okay, so the positive charge, okay, is moved from one conducting plate to another. So it will move in this direction of Fe. Okay, and calculate the work done on the charge. Okay, so let's start. So equation W. So in order to calculate the work done on the charge, remember, so W is equal to Q naught, the test charge that refer to the positive nanocoulomb charge, times the delta V, the potential difference between the plates. Okay, so how to calculate the delta V? How to write the relation between V and E? Okay, remember, in order to find the potential difference between the two plates V, it's equal to ED. Okay, okay, kalau awak ingat sebelum ni, equation of the electric field between the two plates is equal to V, the potential difference between the plates, over the distance between the two plates. Okay, so this is the equation. Therefore, V is equal to ED. Okay, so now we need to substitute the second equation of V in this equation. So W is equal to Q naught times ED. okay, where Q naught is equal to 4, exponent negative 9, and the electric field is 1.0, exponent 4, and the distance between the two plates is 5 millimeter. Okay, bukan 5 meter, 5 millimeter. Okay, and it's equal to 2 times 10 power of negative 7 joule. Okay, if you want to calculate the delta V separately, so you can do that, where E is equal to 1.0 exponent 4 times 5 exponent negative 3, and it's equal to 50 volt. So since part B, the question asks you to find the potential difference between the plates, so the answer is 50 volt. Okay, this is the first method. You can use another method. Let's say you want to find what is the work done on the charge, okay, in order to move the charge from positive plate to the negative plate. Okay, so you can still use this equation where W is equal to Fe times D. Okay, remember, equation of work is equal to the amount of force times the distance traveled by the charge. Okay, where W is equal to QE times D. Okay, and here you can see we still have the same equation, and the answer should be the same. Okay, for part A. And for part B, let's say we want to find the potential difference between the plates, and we can use equation W is equal to Q delta V. Okay, so now we can find delta V is equal to W, the work done on the charge, over the amount of charge Q. Okay, so when you substitute the value, so W is equal to 2 exponent negative 7, kita dah kira dekat atas tadi, over 1 exponent 4. And delta V you will get 50 volt. Okay, so we have two methods here in order to solve for these problems. So you can start your solution with equation of W equal to Q delta V, and then you find delta V equal to ED, or you want to start your solution with this equation, since the definition of work is equal to the amount of force times the distance. Okay, ingat tak kita belajar chapter 5, W is equal to, last semester kan, W is equal to FD cos theta, and cos is equal to 0 because the direction of the electrostatic force here is same direction as D. So the angle is equal to 0 lah. Okay, so this is come from the work equation where work is equal to FD. Okay, ini pun boleh. Okay, you akan dapat jawapan yang sama lah. Alright, okay, let's move to the second example. Alright, example 2, we have an electron beam enters at right angle into a uniform electric field between two horizontal plates separated of 5.0 cm apart. Okay, so given that D is 5 cm, alright, and the plates are connected across a potential difference of 1000 volt. Delta V is equal to 1000 volt. Okay, so when the question states that the plates are connected across a potential difference of 1000 volt, that means the potential difference between the plates is 1000 volt. Alright, so given that the length of the plates is 10 centimeter, means that from here, okay, to here is 10 centimeter, okay, and the beam is deflected vertically at the edge of the field by a distance of 2 centimeter. Okay, calculate the speed of the electron entering the field. So now we have the electron here. Okay, so let's say this is the electron and it enters the field horizontally, and we're gonna have U where U is equal to Ux, and then what happened to the electron? It will deflected in this direction. Okay, so let's say at this point V. So the question asks us to find what is the speed of the electron when it enters the field. Okay, kita nak cari U lah, initial velocity. And given that the vertical distance, okay, so given that here is Sy and it's equal to 2.0 centimeter. So now we want to find Ux. Okay, we don't know what is Ux. Okay, so based on this diagram, okay, let's say this, we consider this as a top view. Okay, kita akan buat dua method nanti. Okay, when you consider this as a top view, so when you consider this as top view, so means that when the electron enters the field, so there is the electrostatic force that will attract the electron upward. Okay, so Fe. Sebab itu electron tu akan tends to move in upward direction. Dia akan deflect ke atas. Okay, sebab dia akan tertarik ke positive plate. Okay, since this is the top view, so tak adalah W ke bawah. Okay, therefore total Fy is equal to Ma and F is Fe and this is QE and A is equal to QE over M. Okay, if you consider, okay, let's say I want to use another color. So since we consider the side view, that's mean we need to consider the wake is downward. But since the wake is very small, since the mass of the electron is very small, W equal to mg, okay, so W is equal to mg, and the wake is very small compared to the amount of the electrostatic force. Therefore, if you use either top view or side view in order to solve your problems, you akan dapat jawapan yang sama. Okay, so kita akan cuba tengok betul ke kita akan dapat jawapan yang sama. Okay, so now if side view, we're gonna have total Fy equal to Ma, and here we're gonna have Fe minus Mg equal to Ma, okay, and A is equal to QE minus Mg over M. Okay, look at here. Okay, so now let's start with the top view method. Okay, okay, so I start with the top view. Okay, so now we want to find what is Ux, and the only way we can find Ux by using equation of Sx equal to Uxt. Okay, so we want to find Ux. We do have the value of Sx, okay, but we don't have the value of T. Okay, Sx kita dah ada kan? Since the electron is travel from here, okay, from point A to point B, okay, therefore Sx is equal to 10 cm. Okay, tapi kita tak ada T. Okay, so we need another equation in order to solve for T. Okay, so now I'm going to use, since the question gives us the value of Sy, where Sy is equal to 2 cm, therefore I want to use this equation where Sy is equal to Uyt plus half At squared. Okay, and Uy is equal to 0 since the electron is projected horizontally when it enters the electric field. Okay, so Sy, okay, nilai Sy soalan dah bagi 2 cm. Okay, we can substitute here. And half A here, the value of A, we need to find the value of A, where A is equal to, so since this is the top view, so A is equal to QE over M. Okay, cuba kita substitute the value of Q, the charge of the electron. Okay, so it's 1.6 times 10 power of 19. So E is the electric field, where the electric field is equal to V over D. Okay, so you masukkan kat sini lah. V dia dah bagi 1000 over D. Okay, the separation between the plates is given as 5 cm. Okay, so this one is 5 cm. And then over the mass. Okay, the mass is 9.11. Exponent negative 31. And your acceleration should be equal to 3.513 times 10 power of 15. Okay? And we can substitute here. A is equal to 3.513 exponent 15 t squared. Okay, the value of here TA, and we want to find t. Okay, therefore t is equal to 3.37 exponent negative 9 second. Okay, and finally we can use equation of Sx equal to uxt. Therefore ux is equal to xx over t. You can substitute the value of Sx is 10 centimeter and t is equal to 3.37 exponent negative 9, and it's equal to 2.97 exponent 7 meter per second. Okay, so this is the answer if we use the top view. And how about if we use the side view method? Okay, kita kena consider weight tadi kan. So ini ada acceleration A dia. Okay, let's try to calculate acceleration first. Okay, caranya sama, cuma A saja dia berbeza nanti. Okay, this one is from the side view. Okay, so you can calculate A is equal to QE minus mg over m. Okay, macam tadi saya dah terangkan. Okay, from the side view, you still have the weight of the electron where the direction is downward. Okay, sebab ada yang confuse antara buku dan nota yang ada weight dengan yang tak ada weight. Okay, tak apa, kita cuba buat. You akan nampak jawapan dia nanti. Okay, so let's try to calculate here where Q is equal to 1.6 exponent negative 19 and E tadi kita tahu E equal to V over D where V is 1000 over D is 5 centimeter. Okay, minus the mass of the electron times the gravity 9.11 exponent negative 31. You can see here the mass of the electron is very small. Okay, so times 9.81. Okay, and divide the mass of the electron, okay, which is negative 31. Okay, let's press your calculator. Okay, you can see here. Okay, what is the value of your acceleration? Okay, kalau tadi kita dapat the value of the acceleration here is equal to yang ni kan? Okay, it's equal to 3.513 exponent 15. And how about for the side view? The acceleration is equal to, the value of A is equal to 3.51. Okay, exponent 15. Okay, so when we compare the value of the acceleration, here is 3.51 exponent 15 and here also 3.51 exponent 15. Okay, nampak tak sama kan? So when we consider the side view or the top view, the value of the acceleration would be the same because the weight of the electron is very small. Okay, so now the same method. So bila A dah sama, when you substitute in this equation, you akan dapat nilai SY. Okay, you masukkan dalam ini T pun you akan dapat nilai yang sama. Awak boleh cuba dua-dua cara ni. Okay, finish example 2. Let's proceed to example number 3. Okay, example 3. Here we have a diagram and the diagram shows an electron entering a charged parallel plate with a speed of 5.45 times 10 power of 6 meter per second. Okay, so in the diagram, we have the electron here, where the electron entering the electric field with U, where U here is equal to Ux. So given that Ux is equal to 5.45 exponent 6 meter per second. Okay, please take out all the informations that given by the question. Okay, so in this diagram, we have the value of the length of the plate is 2.25 centimeter And it's actually the value of Sx, which is 2.25 centimeter. Okay. And what else? So the question states that the electric field produced by the parallel plates has deflected the electron downward by a distance of 0.618 centimeter at the point where the electron exits. Okay, so this is the path of the motion of the electron. So since when the electron enters the field, what happened? There is the electrostatic force which is downward. Okay, so this I consider as the top view. Okay, because I want to ignore the wake of the electron. So since this is the top view, so we just have the value of Fe. Mana direction W dia? Bila the top view, the direction of the W is into the page. Okay, so now what happened to the electron will deflected in this direction, and it will exit the plate with the velocity of V, the final velocity. Okay, remember V is equal to, okay, ini saya saja recall, where V is equal to Vx squared plus Vy squared. And given that, okay, the question gives you that the value of the vertical distance is 0.618 centimeter. Okay, maknanya daripada sini tadi kan? Okay, yang orange color until the final position here. Okay, so this is Sy. Okay, where Sy is 0.618 centimeter. Okay, and yeah, that's all the informations that we have from the question. Okay, so now we want to calculate the magnitude of the electric field. Okay, first we want to calculate what is the electric field, the magnitude of the electric field. Okay, so let's write A. Okay, we want to find E. Okay, so we can use equation E is equal to VD, but in this case, we don't have the value of the V for the potential difference and also D. Kita tak ada kan? So we cannot use this equation. Okay, so if from acceleration, so A is equal to QE over M, therefore, okay, E is equal to, okay, rearrange the equation. E is equal to AM over Q. Okay, so I want to use this equation in order to solve for part A. Okay, I do have the value for the mass of the electron and the charge of the electron here, but I don't have the value of the acceleration A. Macam mana kita nak cari A? Okay, so now we need to proceed with another equation, which is, okay, since we have the value of Sy, Sx, okay, dan Ux. Okay, so now I will start with Sy. Okay, kenapa saya mula dengan Sy? Because I want to find the acceleration. So Sy is equal to Uyt plus half Et squared. Okay, look at here. This is my second equation. But still, I cannot solve this problem since I don't have the value of T. Ini kita boleh selesaikan kosong. Since Uy is equal to 0, Sy kita ada tak? Ada. Kita ada kan? Which is Sy is equal to negative 0.618, and it's equal to, okay, so this is actually negative because the direction is downward direction. Okay, so half Et squared. Okay, so it's equal to half Et squared. Okay, A kita tak ada, kita nak cari A, we want to solve for A, and we still have another unknown here, which is T. Okay, kita tak ada T. Then I proceed to the another information that I have, which is Sx, where Sx is equal to Uxt. Okay, you can see here, from this equation, I can solve for the value of T. Okay, jadi bila you jawab soalan exam, you tengok apa maklumat yang soalan tu bagi. Okay, and try to solve the question one by one based on the information given. Okay, so now you can find T. Since we have Sx and Ux, So we don't have problem to find t, where t is equal to, so this is 2.25 centimeter. Make sure you change to meter. And ux is 5.45 exponent 6. Okay. And t is equal to 4.128 times 10 power of negative 9 second. Alright. So now I want to substitute t, okay, into second equation. Okay, let's say this is my first equation and this is my second equation. Okay, so I want to find a, right? So it's equal to, so cancel the negative. So 0.618 equal to half a, t is equal to 4.128 exponent negative 9 squared. Okay, and press your calculator. So a is equal to, okay, berapa a? So a is equal to 7.25. Okay, awak tolong check ya. 7.25 exponent, okay, exponent 14. Okay, exponent 14 meter per second squared. Okay, so kita dah dapat a. Then we want to substitute the value of a into the first equation. Okay, so let's proceed. Okay, since we want to find what is E, so E is equal to AM over Q. So we want to substitute A into that equation. Okay, so we want to find E equal to AM over Q. A tadi kita dapat 7.25 exponent 14 times the mass of the electron, 9.11 exponent negative 31, and E is equal to the charge of the electron is 1.6 exponent negative 19. Therefore, the magnitude of the electric field is equal to 4129.9 Newton per Coulomb. Okay, so we finish part A, and how about part B? So we want to find what is the speed of the electron when it exits the parallel plate. Okay, so look at here, look at the diagram. So this is the value. The value given is the initial velocity u, where u is equal to ux. But now at this point, when the electron exits the parallel plates, we want to find what is the value of v. Okay, where v is equal to vx squared plus vy squared. Okay, and we know that the value of vx is equal to ux, and it's equal to 5.45 exponent 6 meter per second. And how about vy? So we need to calculate vy, where vy is equal to uy minus at. Okay, kenapa saya guna minus? Okay, because the direction of the motion is downward. Therefore, the direction of A should be negative, right? Okay, so now Vy is equal to, since Uy is equal to 0, and the acceleration, okay, we have calculated the acceleration just now, where acceleration is equal to 7.25 exponent 14 times the t, and t is 4.128 exponent negative 9. Okay, tak muat kat sini. Okay, therefore Vy is equal to, okay, the direction Vy, so negative 2.99 times 10 power of 6 meter per second. Okay, so this is Vy. You can see here the negative sign showing that the direction of the electron for Y component is downward direction. Okay, kalau kita refer kepada gambar yang kita lukis tadi, okay, diagram kita pun, okay, at this point we have Vx and direction of Vy is downward. Boleh? Okay, good. Okay, so now we want to find V. Therefore, V is equal to, we can substitute Vy and Vx. Then you will get your answer is equal to, saya terus tulis jawapan, and it's equal to, okay, ini Vx awak tadi, just substitute Vx and Vy in this equation, Vx squared plus Vy squared, and take the square root, and V is equal to 6.22 times 10 power of 6 meter per second. Okay, so this is the answer. Okay, so soalan nak kira the speed of the electron. Okay, dia nak speed saja, bukan velocity. So speed is the scalar quantity. So I just leave my answer with the magnitude only. So tak perlu direction. Okay, so finish example 3. Let's proceed to the last example. Okay, now let's look at example number 4. So this example gives you a diagram where the diagram shows a section of the deflection system of a cathode ray oscilloscope and electron traveling at a speed of 1.5 times 10 power of 7 meter per second. So now it's given that here is the UX value. Okay, and the electron enters the space between the two metal plates, and the electron enters the space between two metal plates where the length of the plate is 60 millimeter. Okay, so given that the electric field between the plates is, so E is given as 4.0 times 10 power of 3 volt per meter. Okay, so kalau you tengok unit ni volt per meter, tapi bila you jawab soalan, tolong tinggalkan jawapan dalam dalam Newton per Coulomb. Okay, tolong bagi dalam bentuk ini unitnya. Boleh? Okay, good. Alright, question A. Okay, copy the figure and sketch the path of the electron in between the plates and after emerging from the electric field. Okay, so since this is an electron, so okay, for A, okay, you must have your positive and negative plate. So let's say this is positive and this is negative. Okay, so when the electron enters the electric field, okay, so it will deflected to the upward direction. Okay, so in this direction, so dia akan deflect ke sini lah. Okay, ke atas. Okay, so why? Kenapa electron tu akan deflected ke atas? Because electron will be attracted to the positive plate. Okay, so when it leave this plate, so we can calculate what is the final velocity here. And here is U. Okay, awak lukislah sikit dia punya deflection tu. Kita try adjust sikit. Kurang lah. Okay, macam tu. Okay, dia punya direction. Okay, so how about question B? Okay, so now for question B, find the magnitude and direction of the acceleration of the electron in between the plates. Okay, so let's say we consider this as a top view. So let's say we consider this as a top view. If you want to use the side view, okay, you need to consider the weight. Okay, remember for the side view, acceleration is equal to QE minus mg over m. Okay, macam kita buat tadi lah. Okay, for the top view, so we have A is equal to QE over m. Okay, kalau you kira, you akan dapat nilai A ini sama. Okay, macam yang kita dah buktikan tadi. Okay, so since I consider this as a top view, so I want to find the acceleration is equal to QE over m. Okay, so when I substitute all the values, which is 1.6 exponent negative 19, and the electric field is given 4 exponent 3, and the mass of electron is 9.11 exponent negative 31. Therefore, A is 7.03 times 10 power of 4 meter per second. So this is the answer. And how about the direction? And the direction is upward. Okay, since the electron tends to deflected in upward direction. Okay, so now part C. Calculate the vertical and horizontal components of velocity of the electron when it emerged from the space between the plates. So we want to find what is Vx and what is Vy. Okay, so since we know that Vx is equal to Ux and it's given in the question, the answer is 1.5 times 10 power of 7 meter per second. Okay, but for Vy, we need to find Vy, where Vy is equal to Uy plus At. Okay, so this is positive since the direction is upward direction. Okay, so Uy is equal to 0. So this should be equal to 0. And yeah, we don't have the value of t here. Okay, we want to find Vy, but we don't have t. So we can find t by using the equation of Sx equal to Uxt. Kenapa saya guna equation ni? Sebab saya nak cari t and I do have the value of Ux and Sx, where Sx is 60 millimeter. Okay, so t is equal to Sx over Ux and Xx is 60 millimeter over Ux, where Ux is 1.5 times 10 power of 7. Okay, therefore, t is equal to 4 times 10 power of negative 9 second. Bukan, ini bukan jawapan. Okay, so masukkan kat sini lah. So now we substitute here. Therefore, Vy is equal to A 7.03 exponent 4 times the time is 4 exponent negative 9. Vy is equal to 2.81 exponent 6 meter per second. Okay. The last one, part D. Okay. Use the answer in C to find the angle through which the electron had been deflected. Okay. So we want to find in which angle. So let's say this is V. Okay. So this is Vy and this is Vx. So we want to find what is the angle here. Okay. Which is theta. Okay. So by using equation, so D is equal to inverse tangent Vy over Vx. So we can straightly substitute all the values for Vy and Vx. 2.81 exponent 6 over berapa tu? Over Vx tadi berapa? 1.5 exponent 4. Is it? No. 1.5 exponent 7. Okay, so what is the answer? Okay, so before I give your answer, so what is the answer? Okay, so before I give you the answer, okay, please share this video if you think it will help your friends. Support saya dengan menekan butang subscribe. Okay, so final answer theta is equal to 10.6 degree. Okay, so that's all. We finished discuss all the examples. Okay, so see you in the next video. Okay, bye and assalamualaikum dan selamat sejahtera.